I am a software engineer in Virtus Lab, and today I'm going to show you Lrrow, which is a functional library written in Kotlin by 47 Degrees company from Italy, which is known from brilliant functional programmers, especially Scala ones. We will start with some theory, but it is really simplified. And at the end of each slide, I will ask you if everything is clear, because I want to be sure that everyone understands it when we move forward and get to practice. So first definition, type constructor. It is any class or interface that has at least one hole for a generic type. For example, list of A. List of int isn't a type constructor because it's already parameterized. It is a proper type. Is everything clear? Any questions? Okay. The second definition, kind. Kind is a type of type constructor. A single asterisk is a proper type. For example, int or list of int. Asterisk to asterisk is a unary type constructor. For example, list of A. And asterisk to asterisk to asterisk is a binary type constructor. For example, either of L of R. We can partially apply this generic parameters. So we can at first apply this all type, then R, and finally receive either type of some type L and some type R. Is everything clear? Some questions? Okay. And higher kinded types. Those are types of nested type constructors. This concept is similar to higher ordered functions, which means functions that take other functions as arguments. And an example of higher kinded type is functor of C of A, which is asterisk to asterisk and then to asterisk. And higher kinded types aren't supported by Kotlin, also by Java and many languages. In fact, they are supported by Scala, but that's a different story. So if Kotlin doesn't support higher kinded types, what is Lrrow's workaround to them? They provided a higher kind annotation, which generates some useful classes, type aliases, and functions for us. For example, it generates for something class, which is something like marker class, a type alias that translates kind interface, which is the Lrrow's workaround to higher kinded types. We cannot nest generic types, so we simply write them one by one next to each other. So we flatten this structure. And the third generated thing is function fix, which takes us from the world of Lrrow and higher kinded types to simple containers like option. Is everything okay? Some questions? Okay. Type classes. Very important thing. They defined a set of functions associated to one generic type. They have no state. And they are like interfaces in object-oriented programming. And time for practice. How to use higher kinded types with type classes. Let's take a functor as an example. A functor is a type class that specifies how to transform the content of any container F We have a map function which is declared on our container f of a. It takes a function from a to b and produces our new container f of b. How to get an instance of a type class? Because here we have a relationship which isn't is a relationship but has relationship. So we annotate an interface which extends a functor with instance annotation, and we basically override a map function, in this case with map from list k type. We can check if we correctly implemented the type class, because Lrrow provides a test suite called loss, and we can simply execute these tests and check if everything is all right. How to use an instance of the type class? Type classes group constructors and extension functions on kind of f and a, not a concrete type which we implement. And to access these extension functions, we need to be in the scope of a type class. That is, the type class object has to be bound to this. And Kotlin provides two ways of achieving this. The first option is standard library functions, run and when. They differ between themselves by that run returns a value and when doesn't return a value. And for example, we can create a multiply by 2 function which takes our functor instance and our container f of, for example, int. Then we use run function on the functor instance, and we can simply map over our values in our container and multiply them by 2. We can pass it an option, a try, and all other implementations of this type class. Bonus here, functor has one useful method which is called lift, which lifts a function to the functor context. For example, we can lift length function from string and pass its sum of 1 to 3, for example, or none, and receive an option result. For more type classes, you can check the documentation. The second option to bring the scope of the type class is by extension functions. Again, we declare multiply by 2 function, and it takes only our container f of int. And then we use our marker class, which was generated by higher kind annotation, run extensions method on it, and we are in the scope of our functor. And then we can simply pass it an option of 1, for example. Okay, the next concept which is provided by Lrrow are data types. They are abstractions that encapsulate one reusable coding pattern, for example, option. To become a type constructor, they implement the interface kind for one or more generic parameters. Data types work over themselves, never directly over the values defined by its generic parameters. They don't modify them. They work the same for all generic parameters. What are the problems with exceptions that we could solve with data types? For example, when we invoke a function that is async and we use a try-catch block, we potentially may not catch the exception because it could be thrown in a different thread. That's one. Because of the power of jumping and stopping computations, exceptions have been abused even in core libraries for flow control. And throwable is an open hierarchy where you may catch more than you originally intended to. Everyone knows the catch block with exception E, and boom. And also thrown exceptions are usually omitted in a function signature, so one cannot be sure that it doesn't throw an exception. And what are data types for error handling? Option is a data type that represents an absence of a value, either holds a failure on its left side by convention, or a success on the right side. It is right biased, which means that the map and flatMap functions will work on the right side. Try, which is like either but with throwable on its left side, and it is preferable in functional programming. And also validated, which is like either but is used to accumulate errors. And now I will show you validated, how it works. Validated returns the result of aggregating multiple calculations that can fail and also aggregates errors. And for example, we have a config which consists of URL and an invalid port. And then we want to parse and validate it. And the result of this validation is invalid, and it includes an invalid field port. More Arrow data types. We have list K, which we've seen previously. It wraps over the list from Kotlin, and it makes it a type constructor. It also implements many operators from type classes. For example, it has a fault write method. Sequence K is like Java stream, but has also more type classes instances. We have also non-empty list, set K, map K, state, and so on. Arrow also provides something called monad comprehensions. With its help, we can write a nested functional code with flatMaps and maps, like this on the left side. And it's arguable if this code on the left side is better. I think I like the right part most, but when the nesting level is higher, for example 4, I think that the left side will be better. And one question, what will be the result of A plus B plus C when one of options is empty? What is the answer? Yeah, one of options is empty. What is the result of A plus B plus C? Yeah, what is... Yeah, it's an option, but with, yeah, empty one, exactly. And optics. Optics are abstractions that update immutable data structures in an elegant way. We just annotate them with an optics annotation, and we can use it like this. We declare an optional, don't mistake it with Java 1. We specify the path to the field that we want to update, and we run modify method on the optional, passing our object that we would like to modify and the transforming function. It's much more elegant than the second option with ugly nested copies. Okay, Arrow also has an RX integration. It's again a monad comprehension, and we can write nested flat maps and maps with like it was a synchronous code. And that's all. Resources. The first link is documentation to Arrow. The second one is documentation of cats, which is an analogical library written in Scala. The third one is a paper about higher kinds in Scala. And the last one is a really nice article about articles, applicatives, monads, and it shows in pictures all of them. I really recommend these links. Any questions? We can switch to Polish, I think. I think that we should keep a balance between. Okay. Okay. Andrzej asked, what is my general opinion about Lrrow? Is it worth to use or not? I think that we should keep a balance between hardcore functional programming and, let's say, rational thinking. Because I think that our code should be maintainable and understandable. And I think that Kotlin doesn't support these functional concepts well. So I think that these simple concepts that I have shown are worth to use, but maybe some more advanced concepts, not necessarily.
So do you think some kind of support for higher kinds types or other things in functional programming should be provided by language itself? So should future releases of Kotlin provide something like that?
Okay. Pavel asked me if do I think that concepts like higher kind types should be supported by languages, and if Kotlin should also support them. I think that there are languages which should support them. I'm not sure about Kotlin, and in fact I think that the creators of the language are not sure too, because an issue on GitHub is open for a long time and they didn't implement it, so I think that they also want to keep a balance between everything.
Native typeclasses in Kotlin. I think it's done by the same guys as Lrrow.
Okay. Other questions?
Lrrow is based on the source generation. Yes? Lrrow is based on the source generation. So do you find any problem with that? I don't know, sources doesn't compile, or there is like too big, or some other problem with that?
Sorry, I'm not sure if I understand correctly.
I can come here. So Lrrow is based on the source generation. So it's generated sources for me.
Yeah.
And is it working fine? Do you have any problems with that?
I didn't have any problems, but I didn't play with it much. So maybe in some advanced projects there are some problems, but I haven't got anyone.